Hello everybody. In this video, we are going to go over 2019 for response question number 2. So if we look at this problem, this is a polar problem. So given polar curve, S is a region bounded by the graph of polar curve, r theta equals this function, where theta is from 0 to square root of pi. So briefly look at the graph, theta equals 0. R equals 0. So it starts from the origin. And when theta equals square root of pi, it will come back. Sine pi is also 0. So this is the orientation of the curve. And also keep in mind, R is the distance from the point on the curve to the origin. So part A, find the area of S. So as we know, area formula equals 1/2 integration from theta 1 to theta 2 r squared d theta. So for this problem, the area will be given by 1/2 from 0 to square root of pi r squared. Just need to plug this function in. Don't forget squared and 1/2 here. And now you can use your graphing calculator to evaluate this, and the answer you get will be approximately equal to 3.5343. So once again, I want everybody to at least keep 4 decimals. And when we plug this into your graphing calculator, you can treat theta as variable x. It will be the same thing. I think the only time you treat theta as a polar coordinates is when you plot the polar curve in your graphing calculator. B, what's the average distance from the origin to a point on the curve? So first, we have to find the distance. The distance from a point to the origin, the same thing as our function r theta. So this is the distance function. Now we are trying to find the average distance, so the average value of the distance function. Don't forget the average value of any given function f(x), 1 over b minus a, integration a to b f dx. So in this case, instead of x, we are using theta. So 1 over pi, radical pi minus 0. Integration from 0 to square root of pi. R will be 3 radical theta sine theta squared d theta. So you can plug this in your graphing calculator directly, and this will give you approximately 1.5800. And treat theta here as x when you use your graphing calculator. So C, there is a line through the origin with positive slope m that divides the region into 2 regions with equal areas. Write but don't solve an equation involving 1 or more integrals whose solution give you the value of m. There's a line going through the origin, and the slope equals m, and the 2 areas will be equal to each other. So we are going to use the equal area to set up the equation. However, we have to find at which angle of theta, okay, you split the whole area into 2 half pieces. So this is a very good point. As we know, how do we first we have to relate this slope and the angle theta here. So given the slope of the line, as we know, the slope should be equal to tangent of theta. And from here, theta equals inverse tangent of m. So after we solve for the theta, the angle theta, we can set up the equation now. The area, we are going to use S1 equals S2. Or you can use S of 1 equals 1/2 of the total area. So S of 1 will be from 0 to theta. R squared d theta 1/2 equals 1/2 from theta to radical pi r squared d theta. This is one of the equations you can use, or you can use 1/2 0 to theta r squared d theta equals 1/2 the total area we solved before from the previous problem. I'm going to just copy this down. Radical pi r squared d theta. And this is 1/2 3.5343. Half of the total area. So either one will work. So the confusing part is you have to relate the slope to the angle of the line. So this is part C. Let's have a look at part D together. So for K is positive, let A of K be the area of the portion of the region S that is also inside of the circle R equals K times cosine of theta. Find the limit of K goes to infinity, A of K. So after reading the problem, it's a little bit confusing because we have so many variables here. We have K, we have theta, and we have limits. So in order to find the limit here, so first we have to see what is A of K look like. If we can find the function of A of K, then we can find the limit very easily. So a lot of students get so nervous when they read the problem, they have no idea what's going on. It might happen to anybody. So what did I do is, first, I have a look. As K goes to infinity, that means K keeps increasing. So I plug in some values of K. So this is your original function S. We want to find the portion of S also inside of the circle. So when K equals 1, it's a circle here. K equals 1. And that's the area we are talking about. Portion of S and also inside of a circle. And K equals 2. Use another color. So this is 1, this is 2. My graph is a little bit off. So this is K equals 2. And as you can see the pattern, as K increase, you see your point of intersection will be getting closer as K goes to infinity. The point of intersection will be at pi over 2. Area A of K as K goes to infinity will be directly equal to 1/2 0 to pi over 2 r squared d theta. Right, so this is a very important step, pi over 2 here. So when after we plug this into our graphing calculator, this gives us 3.3245. Let's have a look at how they grade this problem. So let me copy this answer here. If you have any questions after I explain this, let me know. So for this problem, 2 points, 2 points, 3, and 2 points here. So for part A, the integration, 1 point. Final answer, 1 point. For part B, same thing. Average value, the whole integration, 1 point. 1 point here, 1 point here, and 1 point here. And any other of this equation, 1 point. Depends on which one you choose. And the last one, theta equals pi over 2. As long as you figure out theta equals pi over 2, 1 point here. And final answer, 1 point.